How are they going, my dearest time legend learners? Welcome to another quarter of Earth Science. Here in Senior High Tech, I am glad that you are all safe and ready for another adventurous and amazing learning journey today. I am your Earth Warrior Buddy, Teacher Leo, and together we will learn, discover, and enjoy the exciting world of Earth Science. If you are ready to learn, please listen carefully on today's discussion. It's trivia time! Did you know that the Earth is estimated to be 4.54 billion years old, plus or minus about 15 million years? Scientists have discovered the Earth searching for the oldest rocks for regulatory dates. In northwestern Canada, they discovered rocks about 4.3 billion years old. Then in Australia, they discovered minerals about 4.3 million years old. Researchers know that rocks are continuously recycling due to the rock cycle, so they continue to search for data elsewhere since it is thought the bodies in the solar system may have formed at similar times. Scientists analyze moon rocks collected during the moon landing and even meteorites that have crash-landed on Earth. Both of these minerals dated to between 4.4 and 4.5 billion years. The first geologic timescale that have included absolute dates was published in 1913 by the British geologist Arthur Holmes. Are you excited for another amazing Earth science adventure? Let's begin! But before that, let's play a game called Arrange the Word. Here are the mechanics of the activity. I will flash a jumbled letters and with its definition. Guess the jumbled letters in 5 seconds. Are you ready to play? Let's go! Number 1. It is any method of measuring the age of an object or event in years.
3, 2, 1.
If your answer is absolute dating, then you are correct. Number 2. It is a method of determining the absolute age of an object by comparing the relative percentage of a radioactive parent isotopes and a stable daughter isotopes.
3, 2, 1.
The correct answer is radiometric dating. Number 3. It is a process in which a radioactive isotopes tends to break down into a stable isotope of the same element or another element.
3, 2, 1.
Great! The correct answer is radioactive decay. Number 4. It is the time required for half of a sample of a radioactive isotope to break down by radioactive decay to form a daughter isotope.
3, 2, 1.
If your answer is half-life, then you are correct. Let us discuss this further, so stay focused and don't go away. So our topic for today is determining the geologic time using relative and absolute dating. And for the learning competency, explain how relative and absolute dating were used to determine the subdivisions of geologic time. And at the end of the lesson, you are expected to define geologic timescale, describe relative time and absolute time, and differentiate aeons, eras, periods, epochs, and ages. Dramatic changes are taking place in the Earth system that greatly affect human beings. From global warming to earthquakes, we need to understand these in terms of their causes, their rates, and their long and short effects. Earth's history enables us to understand these changes which no human being has ever seen and to relate them to modern changes. Such events includes the rise and extinction of dinosaurs, the formation of Grand Canyon, the spread of huge ice sheets over what is now Canada and the northern US. We now know through radiometric dating that the unchanging laws of physics and chemistry have had billions of years to work on Earth. Even the infinitesimal rates vast changes have taken place that would be invisible on the scale of human history. Also, rare catastrophic events have made by big changes over short periods, but humanity has only witnessed and recorded few of these. Even our short career as observers, it seems reasonable, but we also use the past to understand the present. The geologic timescale, or the GTS, is a system of chronological dating that relates geological strata or stratigraphy to time. It is used by geologists, paleontologists, and other earth scientists to describe the timing art relationship of events that once occurred, also allowing them to accurately find the times when different creatures were fossilized after carbon dating. Geologic time is usually divided into two forms. Number 1 is relative dating. Relative time or relative dating is the physical subdivisions of the rocks found in the Earth's geology and the time order of events they represent. Most of these subdivisions are recognized globally on the basis of their relative position in the Earth's stratigraphy and their fossil content, means putting events or objects in chronological order without including actual dates or ages. Number 2 is absolute dating. Absolute time or absolute dating refers to numerical ages, often expressed in millions of years before present. These are most commonly obtained by radiometric dating methods performed on appropriate rock types. It is the measurement taken from the same rocks to determine the amount of time that has expired and therefore be used to calibrate the relative timescale, producing an integrated geologic or geochronologic timescale. In geology or archaeology, it is the process of finding a numeric age of rocks or fossils using radiometric dating. Geologic time is the extensive interval of time occupied with the geologic history of Earth. These are the units of geologic timescale based from the segment of Earth history that is represented by and recorded in the planet's rock strata. Eons are the longest portion of geologic time. 3 eons are recognized. The Panerozoic Aeon, dating from the present back to the beginning of the Cambrian period. Next is the Proterozoic Aeon, and the last is the Archean Aeon. Eras are the second longest portion of geologic time. An era is composed of one or more geologic periods. We have 10 eras that are recognized by the International Union of Geologic Sciences. Number 1 is Eoarchean era. Number 2 is Paleoarchean era. Number 3, Mesoarchean era. Number 4, Neoarchean era. Number 5, Paleoproterozoic era. And number 6, Mesoproterozoic era. Number 7, Neoproterozoic era. Number 8, Paleozoic era. Number 9, Mesozoic era. And last, number 10, is Cenozoic era, which about 66 million years ago to the present. Period is the basic unit of the geologic time scale. During this expanse of time, a specific system of rock were formed. Then epochs refer to the unit geological time during which a rock series is deposited. It is as subdivisions of geologic period, and the word is capitalized when employed in a formal sense. Example is Pleistocene epoch. Then ages are a division of geologic time that are usually shorter than epoch, like Ice Age, Age of reptiles, and etc. Did you know that researcher digging in the Philippines Calao Cave found teeth and bones they say belong to a distinct species of an ancient human, which they have named Homo luzonensis? So how can the absolute age of rock be determined? Number 1. Determining the actual age of an event or object in years is called absolute dating. Number 2. Using radioactive isotopes. Letter A. Isotopes are atoms of the same element with a different number of neutrons. Letter B. Radioactive isotopes are isotopes that are unstable and break down into other isotopes by a process called radioactive decay. Letter C. The radioactive isotopes is called parent isotope, and the stable isotope formed by its breakdown is called the daughter isotope. And letter D. Half-life is the time needed for half a sample of a radioactive element to undergo radioactive decay and form daughter isotopes. And number 3 is radioactive dating. Letter E. Scientists study the amounts of parent and daughter isotopes to date samples. And letter F. Finding the absolute age of a sample by determining the relative percentage of a radioactive parent isotope and a stable daughter isotope is called radiometric dating. How relative and absolute dating were used to determine the subdivisions of geologic time. Let us practice your rock understanding by having an activity called fact or bluff. Here are the mechanics of the game. The statement will be flashed on your screen. If the statement is correct, the answer is fact. And if the statement is wrong, the answer is bluff. Just raise your hand if you want to answer. Are you ready? Let's begin. Number 1. The geologic timescale is a system of geological dating that relates geological strata or stratigraphy through time. It is a fact or a bluff. You're correct. Your answer is fact. Number 2. Absolute times, the physical subdivisions of the rocks found in the Earth's geology and the time and order of events they represent. It is a fact or a bluff. Excellent. The correct answer is bluff. Absolute time should be relative time. Number 3. Cenozoic era is about 66 million years ago to the present. It is a fact or a bluff. Very good. The correct answer is fact. Number 4. Periods are divisions of geologic time that are usually shorter than an epoch. It is a fact or a bluff. You're right. The answer is bluff. Periods should be ages. And the last number is number 5. Half-life is the time needed for half of a sample of a radioactive element to undergo radioactive decay and form daughter isotope. It is a fact or a bluff. You're correct. The answer is fact. To sum up, saving our Earth and its environment becomes highly important as it is provide us food and water to sustain life. The society's well-being depends on the planet. The Earth provides essential things such as food and water that all living things need, so it is our responsibility to take care of it. Congratulations, my dear students. I hope you learned a lot today. Once again, I'm your pro teacher in Earth Science, Sir Leo.